So ek gaan nou na Newton's wette, Newton's laws. In your booklet, your exam booklet, I want you to go to page 10, bladsy 10. And my aim today is to try to do question 11, 13 and 15. 11, 13 and 15. Okay, and in the bookie, in this booklet, obviously, fantastic. Please use this to study for Newton's laws, Newton's wette. Okay, the antwoorde is hier agter en die answers are at the back there. And if you need information from it. Dan hoe werk hierdie boekie? Ek het al gesê, maar ek sê maar net weer. This booklet, let's look at Newton's laws. Starts at question 1, obviously. Question 1 on page 7. En dan gaan dit tot by bladsy, vraag 18 op bladsy 12. Those are all Newton's laws. En dit is al die ou past papers, okay? So die vraag 1, question 1 is 2014's question paper, 2014 se vraestel. En dan die laaste ene is 2021 se vraestel, because this is last year's booklet. Okay, so as I guys, if I were you, I would start at the last question and then work back. But in 2014, they were still trying to figure out how to ask this syllabus. Want toe die syllabus helemaal verander. Okay, so kom ons kyk gou by vraag 11, question 11. They say, twee voorwerpe P en Q wat op 'n horisontale oppervlakte rest, is met 'n ligte onrekbare touwtjie verbind. Die houers het massas bla 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 bla. There's a constant force F. Works on 5 kilogram. Die twee houers beweeg nou, and very important, they are moving to the right at a constant speed. 'n konstante spoed van 2 meter per sekonde. Constant speed. Bing 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 bing. Newton se eerste wet. Newton's first law. Maar nou kan jy Newton se eerste wet vir my sê in woorde. Kijk ou.
Wanneer 'n voorwerp staan by die kant van hulle is vol konstant is nou dan vol haar. Tensy nie nou dan like that.
Dat is regtig goed. Ja, pragtig. Alright. And then they also say give Newton's first law. So that is your second clue for your working with Newton's first law. Nou vir al of jou, beteken 'n benoemde vrye kragte diagram vir houer Q, and then you can see it counts 4 marks. 4 marks means 4 forces. Okay. Now, 'n paar goed wat ek hier vir jou wil sê. Remember, grade 11 I was making your question paper, so ek het jou op 'n sekere manier geleer in voorbereiding vir graad 12, preparation for grade 12, but in grade 12 we want to fine tweak it. Nou, ek het vir gesê laas jaar, there's 2 objects, so how many force diagrams are you going to draw? 2. So alhoewel ek net vir die een vraag teken jy albei. Nou, in graad 12, because they're asking specifically for Q, in this question, in hierdie vraag, teken jy net Q-sinne. For yourself, you are also going to draw P's. Of yourself, teken jy albei, vir die vraag antwoord jy net vir Q. Okay, so what I advise you to do is voordat jy eers, before you even write 11.1 to write Newton's first law, voordat jy dit doen, before you do that, you are going to draw the diagram for yourself, die 2 diagramme, and then you're going to answer the questions. Okay, so dis wat ons gaan doen ter voorbereiding. We want to draw for Q and we want to draw P. Okay, vir Q het ons gravitasiekrag na die middelpunt van die aarde. Normaalkrag loop terug op die oppervlakte. You can say I'm going to go relatively fast. Ek gaan nou nie baie vrae vra nie, want ek wil baie werk doen in 40 minute wat oor is. Okay, ons het spanning in die touwtjie en ons het wrywingskrag in die teenoorgestelde rigting van beweging. Nothing is at a weird angle, so I don't need to split up anything into what. Okay, dan as jy kyk na P, gravitational force, normal force, applied force, Maak seker jy verstaan by P waar ek alles vandaan kry. Did you see that there's frictional force and tension going to the left? Okay, then you see there's F at a weird angle, so ek gaan hom opsplit in sy X en in sy Y component. In his X and his Y component, or parallel and perpendicular. En dan vat ek 'n highlighter and I highlight the forces that are in the same plane, selfde vlak. So ek mag hulle bymekaar optel en aftrek. Okay, so they gave a long list of recommendations wat ons moet doen met julle from last year's question paper, and the number one recommendation at Newton's laws is het hulle gesê asseblief, even though we only ask for one diagram, teach the learners to draw two, teach the learners to split them up, teach the learners to highlight. So at the beginning, do this. Okay, why do I draw this up and down, or highlight this up and down blue and this up and down pink? Aren't they in the same plane? Remember, if these two are connected to one another for whatever reason, if I pull this one to the right, dan gaan die regs gebeur. Okay? But if I pull this one up, is this one going to go up? No. So here is up and down. It's not link between one up and down. Okay. Goed. So dan, nadat jy dit gedoen, after you've done this, now 11.1, Newton's first law, blah 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 blah. Dan 11.2, vra of jy teken die kragte op Q. So you're going to say right for Q. I've already done that. F, N, T, F, K, and F, G. They ask for a label free body diagram. So then you have to say Fn stands for normal force. T is tension. Kinetic friction. Fg is weight or gravitational force. You'll see when you go to past papers in your math, they also use just capital N for normal force, or they use W for weight. Maak eens af. Okay. Ek dink nie daar's vrae hierson nie. I don't think there's any questions here. Then they say in the question, sê hulle vir jou, P het 'n wrywingskrag van 5 en Q het 'n wrywingskrag van 3. Okay, so this is 3 and this is 5. Okay, now I don't have a lot of space left. So, oh nee. Gaan ek op die volgende bladsy aangaan. Nou vra hulle vir jou, bereken die grootte van krag F. They want to know what is the size of this force F. I mean, you can see it counts 6 marks. 6 marks tells you 2 or more. Okay. Goed, nou as ek kyk hier so F, I did not highlight it any color. So to calculate F, I must either calculate Y, and they give me that angle to be 30. So I must calculate Y, and then I must use that angle as 30 to calculate it in some way. Or I must get this X, and then use it to calculate. Okay? Let's look at the pink one, because there's less pink forces. Het ek Fg. Can I calculate Fg? Yes, because I have the mass, 9.8. Do I have Fn? Is Fn equal to Fg? No! Why not? Because it's not the only 2 pink forces. Okay? As dit die enigste 2 pink kragte was, yes, then maybe. Maar hulle is nie. So die kans dat jy gaan kry dat hulle gelyk is aan mekaar is amper 0. Okay. So I can't use the pink forces to calculate F. So ek moet na die geel kragte kyk. I must look at the yellow forces. As ek na hom kyk, I want to calculate Fx so that I can calculate F. I get F car. Do I have T? No. Maar hierso is T. Can I calculate T here? Maybe. Let's see. So, gaan eers na Q kyk. Okay, so I'm going to tell the person I'm going to look at Q. Now it's going at a constant velocity. Constante snelheid, Newton's se eerste wet. Now, please do not start like this. Moenie so begin nie. What they want to see is they want you to see that you use Newton's second law. Okay? And then you say, because it's going at a constant velocity, omdat hy teen 'n konstante snelheid gaan, is die versnelling 0. Because it's going at a constant velocity, acceleration is 0, and that is why F net is equal to 0. Okay, so I want to see that. Dan, wat moet ek nog onthou om te doen, want hierdie twee is in verskillende rigtings. Choose a positive direction. This whole system is going to the right, so I'm choosing to the right to be positive. So I have T minus Fk is equal to 0. T minus 3 is equal to 0, so T is 3 newtons. Okay, hier het ek nou baie uitgeskryf. I wrote down a lot. Okay, this is just for you to follow this thing. T minus Fk, the T minus 3 is like that. Okay, then I'm going to use that T. That T I know now is 3, it means that T is 3. Hoekom kan ek dit sê? Want is dieselfde tou, dieselfde krag. Same rope, same force. So if this is 3, then this is 3. Okay, so if I look at P, and please remember, in a test or an exam, toets of examen, skryf hierdie nou onder mekaar, right? It's underneath each other. Ek skryf nou net langs aan mekaar, sodat ek vir jou die prentjie en alles by mekaar kan wys. Okay, again you start with Newton's second law. And then again after that you write F net is equal to 0. Hoekom? Because this whole system is moving at a constant velocity. Die hele systeem beweeg in 'n konstante snelheid. Still, the right is positive. So we have Fx minus T minus Fk is equal to 0. Okay, so then I just substituted the values. T is 3, ons het hom nou uitgewerk. Fk they gave me as 5, so Fx is 8 newtons. Okay, en nou, dames en here, sê ek goed, I am now going to look at this triangle. They are perpendicular components, so daar's 'n 90 grade hoekie. I have x to be 8 newtons. So I have, from this angle, I have adjacent, aangrensend, and I want hypotenuse, skynsy. So wat gaan ek gebruik? Cos. Calculate that what you get. Kry julle ook dit? Dus F is underneath the line, F is onder. Jy vat hom boontoe en dan die cos onder te vat. Dis 8 divided by cos 30. Okay, 6 punte. Net daar. Next question. Daar sê hulle vir jou. Hierdie toukie, this rope breaks now. And after 3 seconds, while F is still applied on P. Let us draw a velocity time graph for the motion of P and Q before and after the rope broke. Alright, so there you can see their velocity was the same because they were pulled at the same speed of 2 meters per second. Then the rope broke, one went faster, one went slower. Okay, follow 11.4. Write down the time when the rope broke. What is it? 3 seconds. 3 seconds. Okay, so don't overthink it. Done. Now ask which part, X, Y, or Z, represents the motion of Q after the rope broke. Explain your answer. Okay, Kayla, laat ek hoor. Wat sê jy? Hoekom sê jy Y? This rope broke. The force is still applied on P. P now goes faster, faster, faster. Daar's niks meer wat Q trek nie. Nothing is pulling Q anymore because the rope broke, so it will be going slower, slower, slower. Go. So it will be 11.5. It would be Y. Y. The rope broke. Thus, no applied force on Q. Dit gebreek, dis geen toegepaste krag op Q. Thus, F net is smaller than 0. It's kleiner as 0. Or you can say it decelerates. Or you can say velocity decreases. Or you can say it slows down. Okay. Goed, so Newton's first law, you remember something regarding that. Nou wil ek gaan na vraag 13 toe, question 13. As jy kyk dan na vraag 13, is dit net so 'n stappie moeiliker as wat jy gekry het in graad 11. Grade 11, it was just a straight line and then it goes down. Now is hy teen 'n angle. Okay, and they say that a block with a mass of so much is on a rough surface, and there's a rope, there's 2 kilogram block, and it slides. Now they say there, state Newton's second law in words. Marie, daar gaan jy. Nee, wanneer in?
Wanneer jy nie krag is rap en maar beweeg in die rigting.
Beweeg? Ja.
In die rigting
Van
die
netto krag.
dis die
Wat is die rekenaar?
massa.
Nee.
Versnelling is die regulering van die krag en die regulering van die massa.
Annie? Massa van die stem. Okay, wat het ek vergeet om te doen heel eerste? Before direction. Teken, 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 kragte diagramme. Okay, so we have for the 8 kilogram block and the 2 kilogram block. Okay, so for the 8 kilogram block, our forces will be gravitational force towards the center of the earth. Normal force perpendicular to the surface, loodreg op die oppervlakte. Dan het hy daar 'n toegepaste krag, it has an applied force at an angle of 15 degrees. And of nie 'n toegepaste krag nie, dis die spanning, that's a rope. Okay, en dan het ons wrywing, tension. En vir die 2 kilogram krag het ons net gravitasiekrag en ja, spanning. Ek gaan dit nie daar los nie. I'm going to split up tension into its perpendicular components, sy loodregte komponente. Question, why do I not split up FG? Split is gewoonlik om op in loodreg en parallel nie. When do we split this up? When you are at an inclined plane. Dan gaan jy hom opsplit. But when it's flat on a surface like that, you do not split it up. Okay, en dan gaan ek highlight. Okay. Watter kleur gaan ek daai kant highlight? Anyone put up your hand that wants to give a solid answer? Yes, Jabu? Why do you think it's blue? But tension is here. Kom, ons dink gou vinnig. Just think, if this is going down here. Nee, you said same as blue. If I pick this thing up, is this thing going to go up? Nee. That's one up. A different color. Hoekom sê jy so? Joanna. Mosi? Okay, so I say if I am pulling this one to the left, then this one will be pulled up. Eh? So that's what you say. Yeah? Ja, so is nie blou nie. Yes, definitief nie blou nie. Okay, ja? Okay, so the different color is die regte antwoord. Okay, kom ons lees gou die vraag. So hulle sê, stel nie, dis die tweede wet van woorde, shap. Then they say, sorry, I'm going to move fast because I'm deviating now. Sê, teken 'n benoemde vrykragte diagram vir die 8 kg blok. You can see it counts 4 marks. 4 marks tells you 4 forces. Kom ons kyk vir die 8 kg blok. Gaan ons sê 1, 2, 3, 4 kragte. Okay, I'm not going to redraw it now, but in a test, you take this and you redraw it without the highlighter and without splitting it up into its components. Hierdie is vir yourself, and then you just do the face value vir hulle. Okay, dan vraag 13.3. Vra hulle vir jou. When the 8 kg block is at point B, as shown, then the angle is 15 degrees. And the acceleration is that. So hulle gee vir jou die versnelling. Nou vra vir jou, gee rede waarom die stelsel nie in ewewig is nie. What is the definition for equilibrium again? Equilibrium is when the resultant is 0, or when the net force is 0, or when you add all the forces together and it gives you 0. Hoekom is dit nie in ewewig nie? Was it not in equilibrium? Because we have acceleration. So we are going to say because the net force is greater than 0 or there is acceleration of 1.32 meters per second squared. 13.3.2 They say use the 2 kilogram mass piece. Kyk na die 2 kilogram massa stuk en bereken die spanning in die toukie en dit tel 3 punte. 3 marks means formula, substitute, answer. Okay? Hulle sê jy moet kyk na die 2 kilogram ene. I'm going to look at that one. The system is accelerating. Hy versnel soos gebruik Newton se tweede wet. F net is equal to m times a. In which direction do you think this 2 kilogram is accelerating? Downwards. Nee? There's no one pulling it up. Okay, in which direction is this one accelerating? To the right. So ek het 2 rigtings wat ek kies as positief. Hierdie ene gaan na regs en hierdie ene gaan na af. You cannot choose to the right to be positive here and up to be positive here. Ek kan. Dan gaan jy antwoord verkeerd wees. Okay? Because if this one is moving to the right, this one is going down. Okay, so dit moet sin maak wat sy rigting sy kies as positief. Okay, so we chose down to be positive. So dit is Fg minus T is gelijk aan M mal A. Okay, how do we calculate Fg again? Mass times 9.8. So ek gaan daar invul, die massa is 2 maal met 9,8. I want the tension, that is the question. This M here, do I fill in 2 or 2 times 9.8? 2, net 2. Hoekom? M is mass in kilograms. Fg is weight in newtons. 2 verskillende goed. Please do not multiply by 9.8. And the acceleration is 1.32. Yes. Okay. En Mossie is op het. Maar julle almal check hoor. Yes. Okay, but remember, now you take the T to that side, né? And then, so it's positive. 16.96 newtons. Ja. Ek dink hulle vra vir jou bereken die grootte. Wag net gou. En net bereken. Ag jy kan dan sê opwaarts. Nee, hoekom kry jy 'n positiewe antwoord? Want ons het klaar gesê minus T. So nee. So as jy gesê het plus minus T of wat ook al, dan moet jy 'n negatiewe antwoord op die einde van die dag kry. Of as jy sê plus T en dan ergens gaan jy goed nie so maak. Okay. 13.3. They ask calculate the kinetic force on the 8 kilogram block. So they want the kinetic frictional force there. Okay. The kinetic frictional force is yellow. So now I'm going to look at the yellow forces. Okay. This whole thing is accelerating, nee? Hy versnel regs. So I'm still using Newton's second law. Mama, focus. It's accelerating to the right, so I still choose to the right to be positive. So it's Tx minus Fk is equal to m times a. Net by so kry ek dit. X minus Fk. Because I'm looking at the yellow forces. Okay. Do I have Tx? No. But I just calculated that T there is 16.96. I know that angle there is 15 degrees. So ek weet wat is daai hoekie. Ek weet wat is daai. Can I calculate Tx? Yes, sin cos tan cos. So dit gaan wees 16,96 cos van 15 grade minus Fk. The mass is 8 kilograms. What is the acceleration? Versnelling? 1.32. They gave that to us. Declan, are you on it? Yes, 5.82 in the unit. Newton. Alright, so ek het net hier langs aan geskryf. I just wrote down here next to it. How do I calculate Tx? We said it is T cos of theta. Okay, so as jy gaan vergeet, kan jy dit jouself neerskryf. Okay, now they ask, I'm going to go to the question. Okay, kan ek weggaan? Gone. Now they ask, as the 8 kilogram block moves from B to C. Soos waar die 8 kg blok van B na C beweeg, is die kinetiese krag tussen die 8 kg blok en die son nie konstant nie. So they say the kinetic force is not constant. Give a reason for this statement. Okay. Now it counts 1 mark, but we're going to write a bit more so that you understand the concept. As it moves closer to that angle, to that pulley. Okay. So kom ons sê die capital. As it moves closer, I want you to see we took this angle here as 15 degrees. Okay. As it moves closer, what happens to the angle? It increases. It becomes bigger. And when you pulley blow presies dieselfde plek, the angle here becomes bigger. So daar is dit met die hoekie. En dan okay, so ek wil net so met teken vir jou. Vraag 13.4. So at the beginning it was here and then it's there. Okay, so die hoekie het vergroot, the angle increased, and if we draw the free body diagram here, so as die kragte diagram teken, dan het ons these horizontal forces. Daai horizontal nie vertical, vertical forces. So when it comes closer, wanneer hy nader kom, then this component will become bigger. Nee? Want die ene word al korter, it becomes shorter, and this one becomes longer. So if this one becomes longer, what happens to the normal force? It becomes smaller. Okay? So as soon as wat hy, but die gravitasiekrag bly dieselfde, the weight of the object stays the same. So as this one increases, this one decreases. And how do we calculate the frictional force again? It's the coefficient times normal force. So because the angle becomes bigger, Y increases, normal force decreases, and thus the frictional force decrease. Okay. Soos as jy sê nou maar ons het hierso. 15 grade, kom ons sê dit is 10 Newton vir wat ons wil hê. En hierso is die hoekie nou wat? Kom ons sê die hoekie is 60 grade, dit is nog steeds 10. Die katroos is bestel, hy kom nader, kyk hierso. X word korter. Die hoekie word korter. So ek stuur hom langer want sy waarde word korter. So ek kyk hom net langer om waarde te doen. So omdat die hoekie korter word van sy waarde ek kan net so doen net. Okay, so because the angle becomes bigger, the value, the size, the magnitude, die grootte van y word groter. Okay, so ek wil nou die hele, I know it comes only one mark, maar ek wil hê jy moet al die stappies verstaan. So, as angle increases, soos wat die hoekie groter word, gaan T se y-waarde toeneem. The y value of T will increase. Thus the normal force value will decrease. And if you look at Fk is equal to Uk times Fn, then that means the frictional force value will also decrease. Okay, then back to the question for all of you. The horizontal surface is now changed with another horizontal surface. Okay, so the type of surface is changed to another material. Will the kinetic force that you've calculated here, will that change? Choose yes or no and give a reason for your answer. Gaan hy verander? Ja, hoekom? Because if you change your type of shoe, okay, if you have dancing shoes compared to running tackies, does your friction on the floor change? Yes. So if you change the type of material, as jy die soort materiaal verander, dan verander die wrywingskoëffisiënt. En dus gaan jou wrywing verander. Okay? So at question 13.5, ander materiaal beteken ander wrywingskoëffisiënt. Dit wil sê of en dan Fk okay. So different material means different coefficient. Different material means different coefficient. According to my formula, friction is equal to coefficient times normal force. So because that changed, the frictional force will change. And they said you must choose yes or no. Yeah, yes. So you do not have to start with yes and then give an answer. You can have yes at the end as well. And I can also say, can you see, I always refer back to the formula. Altyd, vir die vorige vraag ook, het ek na formules verwys. You get a mark for referring to a formula. So skryf 'n formule neer. Moenie dink hulle weet mos van watter formule jy praat nie. Refer to the formula. Altyd. Okay, dan die laaste vraag. Last question 15. Okay. Nou hierso is dit sommer, ek voel nie klomp gemors nie, maar soos klomp moeilik goed in een. There is an inclined plane On the inclined plane, there's another angle. And then op die skuinsvlak, there's a part that has friction and a part that does not have friction. Okay, so hier moet jy kop hou. Dit sê vir jou blok P met 'n massa van 2 kg en ons blokkie 3 kg. Daar's 'n hoekie van 30 grade, bla bla bla. Q, there's a constant force of 14 Newton. There's a rough part and then there's a frictionless part. Look at the diagram. Then they say there's a constant frictional force, konstante wrywingskrag wat op P inwerk daar van 2,5 Newton. Frictional force. Okay. Then they say state Newton's second law in words. That is your clue that you're busy with. Newton's second law. Tja. Goed. Voordat ek verder gaan lees, what am I going to draw? Free body diagrams for P and for Q. Okay. Now, I know some of you struggle with the angles. Nee, maak yourself confused. So, please take your ruler, put your ruler on the inclined plane. Get more or less that angle. Go to your drawing and just draw with dotted lines. Nie solide lyn nie. Liggies, just very lightly with dotted lines. You draw for yourself an inclined plane. Okay, so baie liggies teken jy vir jouself 'n skuinsvlak. Okay, if we look at P, what do we always have? Gravitational force towards the center of the earth. So daar, gravitasiekrag na die middelpunt van die aarde. Then you put your ruler on the inclined plane like that. Sorry. What's the next force that we have? Normal force perpendicular to the surface. So you put it that it makes a 90-degree angle there on your surface. And you teken jou normaalvlak op. I must see the 90-degree angle. Okay? So it's not there. It's not there. Okay? It is there. Is my normal force. Good. Then for P, I have the tension in the rope. And I have frictional force in that direction. Okay? Ek gaan nou terugkom na P2. At Q again, gravitational force towards the center of the earth. Normal force perpendicular to the surface. Applied force at a weird angle. And tension in the rope. Geen wrywingskrag nie. No normal force. Ag nie normal force nie. Frictional force because they say there's a frictionless surface. Wat gaan jy nog doen? Now you're going to split up this in these perpendicular components. Want hierdie is 'n 90 grade, daar is 'n 90 grade. I want this at 90 degrees. So you put your ruler on the inclined plane en jy vat hom af to daar and you draw dotted lines. So that is parallel to the surface. Parallel to the surface. Then you put your ruler so that it's on the normal force. Because it's perpendicular already, it's 90 grade klaar. And you take it down, and you draw your dotted lines. Angles here are very important, not angles. Arrows. This is FG perpendicular, FG parallel. Okay. So selfde ding hier, same thing here. Ek gaan net gou vinnig omkom because I do want to check. And F, force F, I'm going to also split up into its X component and its Y component. Okay, so this is highlight. Okay. So they say, state Newton's second law in words, dat kan jy doen. Teken 'n kragtediagram vir blok P. P, 4 marks, 4 forces, 1, 2, 3, 4. Okay, so please, I'm going to say this again. This you do for yourself at the beginning, bo. Dan begin jy met Newton's tweede wet. En dan teken jy vir P en jy teken hom mooi hierdie keer. You draw it nicely and you do not split it up and you do not highlight. Okay. Then, for 8 marks, 8 punte. They say, calculate the size of the acceleration on block P while P goes through AB. So they just say, for this scenario we have here, what is the acceleration of P? Kan jy net na P kyk? Nee, because P and Q are attached. So this was gaan doen, look at P, look at Q, put them equal to one another, blah blah blah. Julle onthou daai ding. Okay. Right. So I'm going to look at block P first. So ek wil net kry. Okay. F net is equal to m times a. So ek kyk na P eerste. The whole system is accelerating to the right upwards. So ek kies regs as positief. And I'm going to look at my yellow forces. So I have T minus Fk minus Fg parallel is equal to m times a. T I do not know. Fk het hulle vir my gesê is 2.5. How do I calculate Fg parallel again? Sin. So it's going to be, what's my angle there? 30. 2 times 9.8 sin of 30 is equal to 2 times a. Okay, please check. See that you can also do it. Okay, then I'm going to go to Q. Very important, I think we all did it correctly. The arrows here are important, the pijlen, because then you know when you must add and when you must subtract. Nee, anders gaan je waardes verkeerd wees. Hoe gaan ons fx uitwerk? Hulle sê hierdie hoek is 25 grade. How are we going to calculate fx? Sin cos? Cos. So that is going to be 40 cos. And parallel is sin. Please do this underneath each other, nee? And it is of examen. Good, and now we must put them equal to one another. Okay, so stop. Awesome. Dink gou. Weet jy waar ek die waardes vandaan gekry? Do you know where I got my values from? Do you know why I use cost? Do you know why I use sin?
Yeah. Good problem.
Right, any questions, juffrou? Ask ek of jy waar jy die waarde vandaan kry. No question. Okay, so this is a normal question. Nee, ons het baie van hulle gedoen laas jaar. Okay, the only difficult part is the fact that it made another angle. Okay, dan vra hulle vir die laaste vraag. They ask, block P is now past point B. So it is now getrek, it's being moved up, and now P has passed B. So it has passed the friction. Hy sê daar verby die wrywe. How will the acceleration compare now? Hoe gaan die versnelling nou vergelyk with what you have calculated here? So increase, decrease, or remains the same? Give a reason for your answer. En almal sê dit gaan increase. Dit gaan toeneem. Hoekom? Because there's no more friction slowing it down. Alright.